What if the speed of light isn't the end of the road? Have you ever wondered what lies beyond the limits of our universe? What if faster than light travel wasn't just science fiction, but a future reality? Imagine traveling to another galaxy in the blink of an eye, escaping the flow of time, or unlocking the doorway to parallel universes. These aren't just wild dreams. They're serious questions scientists have explored for decades. In this video, we'll dive into the most fascinating theories that challenge everything we know about speed, space, and the laws of physics. From Einstein's cosmic speed limit to exotic ideas like warp drives and wormholes, we're going to unpack whether breaking the speed of light is truly impossible or just very, very difficult. Let's start with the basics. The speed of light in a vacuum is approximately 299,792 kilometers per second. That's about 186,000 miles per second. At this speed, light can travel from the Earth to the Moon in just over 1 second. But why is this important? According to Einstein's theory of special relativity, the speed of light isn't just fast, it's the ultimate cosmic speed limit. Nothing with mass can ever reach or exceed it, because as an object approaches light speed, its mass increases and it would require infinite energy to keep accelerating. This limit is woven into the very fabric of space and time. It's the reason why space travel to even the nearest stars would take years, if not centuries, with current technology. So to break this limit, we'd need to break the rules of physics, or at least bend them. Now here's where things get interesting. In 1994, Mexican physicist Miguel Alcubierre proposed a revolutionary idea. What if we could bend space itself instead of moving through it? This concept, known as the Alcubierre warp drive, suggests a spacecraft could remain stationary inside a warp bubble, while space contracts in front of it and expands behind it, effectively moving faster than light without breaking the laws of physics. Think of it like riding a conveyor belt through space. But here's the catch. The warp drive would require an exotic form of energy, negative energy or negative mass, that we've never observed in usable quantities. In theory, this bubble could allow a ship to cross vast distances in moments. In practice, it remains one of the most speculative and mysterious ideas in modern physics. Still, the fact that it doesn't outright violate Einstein's equations keeps the dream alive. Warp drives aren't the only idea on the table. Enter wormholes, also known as Einstein-Rosen bridges. These theoretical tunnels could connect two distant points in space, allowing instantaneous travel across galaxies or even time itself. Imagine folding a piece of paper and poking a hole through. Suddenly, two distant points touch. That's the basic idea behind a wormhole. But even more mysterious are the strange behaviors in quantum physics. In the quantum world, particles can appear to teleport, thanks to something called quantum tunneling. This allows particles to seemingly pass through barriers without crossing them in the classical sense. While we've observed tunneling in labs, applying it to large-scale travel is still science fiction. Still, both wormholes and quantum phenomena hint at one profound truth. The universe may not be as rigid as we once thought. So with all these theories, From warp drives to wormholes to quantum tunneling, can we actually travel faster than light? The short answer, not yet. The energy requirements are immense, and the materials we'd need, like negative mass, are purely hypothetical. But here's the beautiful part of science. It's always evolving. Concepts that were once considered impossible, like flying machines or moon landings, eventually became reality. Maybe faster than light travel is today's fantasy, but tomorrow's discovery. Until then, these ideas push the boundaries of what we believe is possible. They challenge us to ask the biggest questions. How far can we really go? What are the limits of space, time, and imagination? If you enjoyed this journey beyond the limits of space and time, don't forget to subscribe for more science that bends the mind. Hit the bell icon to stay updated, and share this video with someone who loves asking big questions. See you in the next one.